Salinity measures the total dissolved inorganic solids in water. It is the ratio of the mass of dissolved solids in 1,000 grams of seawater. This diagram shows a sample of 1,000 grams of seawater. In this sample, you find 34.69 grams of salt and 965.31 grams of pure water. The salinity of this sample would be measured as 34.69 parts of salt per 1,000 grams of seawater, or simply 34.69 parts per 1,000. We use parts per 1,000 to measure salinity, and the advantage of using this unit is to avoid using decimals. The major salts of the ocean are chloride, sodium, sulfate ion, magnesium, bicarbonate, calcium, and potassium. The pie chart shows the individual concentrations of each of these salts in 1,000 grams or 1 kilogram of seawater. So one could say that the concentration of chloride in this sample is 18.98 parts per 1,000. Why is the ocean salty? Salt ions enter the ocean primarily through river discharge and volcanic eruptions. The same salt ions are removed from the ocean by adsorption and precipitation, ion entrapment in sea spray, and by biological processes. An example of a biological process that removes salt ions from the ocean is the growth of marine organisms that have shells and skeletons. Chemical reactions at the ridge system both add and remove various salt ions. Because salts are added and removed from the ocean at the same rate, the ocean is considered to be in a steady state. In the open ocean, salinity can vary from 33 to 37 parts per 1,000. In coastal areas, salinity variations can be more extreme. Estuaries or coastal lagoons that receive river discharge will have brackish waters. That means water with lower salinities when compared to ocean salinities. The image shows the salinity values for San Francisco Bay Estuary during December. Note that the lowest values are detected closer to the delta of the Sacramento River. In contrast, landlocked seas, such as the Dead Sea, have limited open ocean circulation, producing hypersaline waters. The Dead Sea has a salinity of 330 parts per 1,000, which is almost 10 times the average salinity of the ocean. As a result of the hypersaline waters, the Dead Sea also has high density and high buoyancy, which allows swimmers to float easily. The world map also shows salinity patterns with latitude. Notice how lower salinities are detected near the poles, peaks near the tropics of Cancer and Capricorn, and dips near the equator. The peaks of salinity near the tropics of Cancer and Capricorn are a result of the high evaporation in these subtropical areas. The equator has lower salinities as a result of increased precipitation, and the poles have even lower salinities as a result of higher precipitation at the polar fronts and sea ice melt in the Arctic.